Welcome to Equation Experts. The one presenting is Dr. Velosti, the nuclear physicist. So today we are going to solve some examples. So our first example is you show that the following expression is dimensionally correct. So we are proving the consistency of this equation. If this equation is actually dimensionally correct. So we proceed to this one. So the first part, the first example. So for A, so T being equal to 2 pi the root of A over G. So consider the dimension, so we can have data there. So a dimension for T is which is a period, is T. Then L is equal to this. Then G is equal to L T div 2, because we're talking about the dimension analysis. We're showing that this equation is actually dimensionally correct. L is actually the length in that case, which is capital letter L. Then gravity is meter per second, because gravity because we're talking about acceleration due to gravity. So it's what, meter per second squared. Meters is a distance, which is actually a length. Then over we have second, which is time, in that manner. Then mathematically we are able to write this in that manner. So that's what we have done here. So with that in mind, considering a constant as dimensionless, because dimension analysis does not recognize a constant, so we can proceed there. So T, this will be like that. So our whole instance of us coming up with this dimension is to ensure that the left hand side is equal to the right hand side. The dimensions are equal on both sides. So we substitute there. So L over L. Then you have T negative 2, that one. So with that in mind, so T, this will cancel with that. So it's more like here you have something like 1 over T to the power negative 2. So if you have x to the power negative 2, same as 1 over x squared, in that manner. Now if let's say you have 1 over this, it means this is just x squared. So that is what it means here as well. So that's what, so this is what you're going to get. So this is going to be, so T is going to be equal to T dot, then the root in that case. Then when you find the root, because there's 2 here, this will cancel with that. So T is equal to T, that man. So we can conclude here and say that this is actually dimensionally what? Correct. So it is what? Dimensionally correct. It is dimensionally correct. So I've proved the first one. So we've proved the first one. Now what about for B? So for B, we're told to show that the area is equal to pi r squared. Considering the dimension, so we correct data. So dimension for area is just length squared, which is L squared. Then r is a distance in meters, so it has to be L. Then we can substitute considering pi as a constant, because you already don't know to say pi is a constant. So the dimension analysis has a limitation when it comes to constants, so it does not recognize them. So we eliminate a constant. So what are we going to get here in this case? So substituting those values, we are going to have L squared being equal to pi r, not pi r, but we substitute the dimension there, so it will be L squared. So this is where I want to eliminate a constant. Here we can actually eliminate a constant. So we can eliminate that. So what you're going to remain with is actually, which also we can say it is dimensionally correct there. So that is for B. Then what about for C? So for C is bit advanced, but with the same concepts we need to know. So for C, we are told to show that V squared is equal to U squared, not U squared, but we're going to have V plus 2gx, because you know velocity is just a derived quantity that is made up of fundamental quantities length, mass and time. No, not mass, but length and time. So what we're going to have is, so V is equal to L, then T not T, so this, we do this. Okay, so this is what we are going to have. It's meter per second. Then V naught is also one and the same thing. Then G is made of velocity, so it's actually just a square of time. So, but remember, this should be -1. This should be -1, because you know it's negative to the power -1. It means it's over that. So that's how we represent it in math. So even this one is like that, because what I mean is, what I'm trying to put across here is, if you have meter per second, it's more like it's 1/s, of which you can write this as m -1, like that. So with this in mind, we can now substitute this. So for velocity, if we distribute we are now distributing this power here, so this will be squared. Then if we also do the same here, we're going to have t per power, this will be -2, and this will be same as this will be squared, and this will be t negative 2 plus so what to do here, I want to erase this part. So this is 2 G is actually, this is actually L. Then you have T, the power negative 2. Then you have X, which is length, because that's a position, or rather length. Then what do we do here? So we're just showing that the right hand side is equal to the left hand side. That's our aim at this point. So this is actually negative 2 there. Now, when you multiply this, when you multiply this will be squared as well. So here what we can do, can do this. So this is what I want to do. So let's try to factorize L squared. So like I want to express this as a single, because I want this to be equal to that. So this will be t to the power negative 2 plus t to the power negative 2. So I've removed the constant because the dimension is. So what am I going to get here is this. Then at this point, this t squared, this will be 2t to the power negative 2. This man. Okay, let me write it properly. So this is the power negative 2. So because it is dimensionless, we can cancel. So that one is not necessary, the 2 is not necessary, because our interest are the dimensions. So you can see that this is equal to that. This is equal to that. You can see that this is what? Dimensionally correct. So this is how you show. So you can conclude here and say it is what? Dimensionally correct. So this is how you solve. So this is how you show that this equation is dimensionally correct. So this is how you show. I believe there is no question at this point. So we're going to solve this other example in the next video.